Today in class we talked about some special forms of quadratics. And what I'm talking about when I'm talking about special forms of quadratics, I'm talking about the difference of two squares, and we'll start with that, which basically means, so the difference of squares, what this means is a squared minus b squared. And so when I have two squareds in there, two square numbers, and they are subtracted from each other, then I can just factor it out to a plus b times a minus b. And an example that's given here, and I'm going to start with an easier example than this, like we did in class today. What this means is if I have x squared minus 9, x is a perfect square, or x squared is a perfect square, minus, and then 9 is a perfect square, and that would be 3 squared. So in this case, I would have x plus 3 times x minus 3. Now, you wonder why I don't just use my square roots and put 9 on the other side of the equation and solve for x. Well, you can do it either way. And we're going to get to that point tomorrow or Thursday, or tomorrow or Wednesday, and you're going to see that x is still equal to negative 3 and x is still equal to positive 3. So another more complicated example of this is 64x squared minus 9. And in this case, you can see that 64x squared is a perfect square, which is 8x squared, that whole quantity squared, minus 3 squared. And so in this case, I would just simplify it to 8x plus 3 and 8x minus 3. So, and you just have to practice it, and you just have to practice seeing it. So, moving on down to the problems A, B, and C, you can see x is a perfect square, 36 is a perfect square. So it's going to end up being x plus 6 times x minus 6 is how we would factor that. Now, in this case, it's the sum of perfect squares. And in this case, this is not what we saw before. So we have to see that you might want to use, you can't factor this any further. It doesn't work. So we're going to move on along to C. And you can see that this is the difference of perfect squares, where we have m squared minus 9 squared. So this becomes m plus 9 times m minus 9 in its factored form. So moving along, you can kind of see that D is the same situation. It would be 2b squared minus 20 squared. So it would be 2b plus 20 times 2b minus 20. So it just takes practice to see, is there the difference of perfect squares? So I just look at there's two terms. I look at my two terms and say, is x squared a perfect term? Is square is 36 a perfect square? And then you go from there. Well, then the next situation is where you have perfect square trinomials. And what this actually means is a trinomial that looks like a squared plus 2, and then I multiply a times b, plus b squared. And this will factor out to be a plus b squared. Now the same situation happens if I have a squared minus 2ab plus b squared, and that factors out to a minus b squared. So let's look at some examples of this. If you look right here, you can see, hey, this is my a, this first term right here is a perfect square, so a would be x. My second term here is a perfect square, that would be 7 squared. And then I have to look here, is this term in the middle my a, which is x, times my c, which is b, which is 7, times 2. And in this case, it is, and it's just subtracted. So in this case, I can see that the situation here is x squared, so that's where I get my first term from, minus, and they did 2, and then I have my x and my 7, because here it would be x, that would be squared, and then this would be 7 squared. And that's what I mean by saying that they are perfect squares. So I multiply these together, and then multiply by negative 2, and then take my 7 and square it. And that is 49. So then I can say it's x minus 7, that whole quantity, squared. I know that's a bunch of words, so let's see what we got. The first situation we have is it's a trinomial, so I'm going to see is it a perfect square trinomial. So I look at this term first, and I can see, hey, that can be 2x squared. This right here can be 3 squared. Okay, so those two are perfect squares. But let's see if the middle term works out. The middle term has to be 2 times 2x times 3. And so that is going to end up being 12x. So in this situation, it's a perfect square trinomial with an addition sign, or my b term is positive. So I can just go ahead and write 2x plus 3 squared. Now, could I do this if I did the x factor and did pants? Absolutely. I could find out the same thing. So, looking here at this next one, I have f, and I have to say, okay, is this term right here a perfect square? And yes, it is. 8a squared. And is 9 a perfect square? Yes, it is. Now my second step is, it's negative, so I know I'm going to have like negative 2. And then if I multiply those two together, 8a times 3, that's 24a. And when I multiply those together, it is negative 48a. So absolutely, I am working perfectly this time. So it's a subtraction for the bx, or for the b term. So I have to say, okay, it's going to be 8a minus 3, and that whole quantity is squared. And you can FOIL it back out just to see. So I know it's a little complicated, but once you look at it and kind of see it and do it over and over and over again, it does get a little bit less complicated. So here I can say that this is 11a to the 4th squared. And my b term here is 8b squared. So it's the difference of perfect squares. So I have 11a to the 4th plus 8b squared times 11a to the 4th minus 8b squared. So that is what you would be doing for each of these. Now h is a perfect square trinomial, maybe. Let's see if we, not right away, but if we factor out the common factor among these, I wonder if it would be. So I'm thinking 2 would be the common factor here. Oh, 2m actually would be the greatest common factor. So that would be 9m to the 4th plus 24m squared plus 16. And at this point, it's in the form where you can start with the perfect square trinomial. But in the end, you still have 2m on the outside. And it's going to end up being 2m times 3m squared plus 4 is going to be your factorization. So that's a little bit about how you do these types of problems.